Yeah. So did you all finish last exercise? So we have done till what? Activation functions, right? Defining activation functions. Okay. So before we start with today's session, let me quickly recap what did we do in the last session for 5 minutes, and then we'll proceed further. Okay. So what did we do in the beginning? What is step 1 for developing an ANN model? We have to import the libraries. Okay. So in libraries we are using NumPy, Pandas and Scalar, right? So we have used NumPy, Pandas and Scalar. NumPy for performing numerical operations when we proceed with backward propagation or defining activation functions or loss function, we use NumPy. For reading the data set we use Pandas, and for other pre-processing and model selection operations we go for using Scalar, right? So we've imported Pandas, NumPy and Scalar. This was step 1. What did we do in step 2? We have loaded the data set, right? So what is the data set that we are working on? So we have loaded data set, right? So we were working on which data set? Breast cancer data set. Okay. So what is the output variable here? Diagnosis. Okay. So here we are performing which algorithm we are using for this? Classification. Okay. So there are two possible outcomes for this particular data set, that is M or B, malignant or benign. Okay. So depending on this we will choose our loss functions, right? So second step was loading the data set. Okay. So using Pandas pd.read function method we have loaded the data set, right? So after loading the data set, what did we do in step 3? Divide the data set or split the data set into dependent and independent. Okay. So dependent is nothing but your output variable, which we generally term as Y. Independent is nothing but your input features. Okay. So we have 14 features, out of which I am dropping one column, that is the output column diagnosis, and I am putting that into variable Y. So as you can see, X is equal to the entire data where I am dropping one column, and that one column is nothing but output column, which I am loading it into variable Y. This was step 3. Okay. What did we do next? We have performed some pre-processing. Okay. What was that pre-processing that we have done? Standardization. Okay. So what is the need for standardization? Okay, to maintain consistent data, or to make sure that all the features have equal importance, we go for standardizing that particular data. Okay. So we have done that pre-processing step. After that, what did we do? The entire data set should be split into training data and test data. So we have 100 samples in the data set that we have given. So I want to divide this data into training and test. Okay. So we use a hyperparameter there, which is called as test underscore size, which will determine the test size data. Okay. So when I put 0.2 there, it is 20% test, so that 80% would be train data. Okay. So this is what we have done. Okay. So after that we started building network. These are the basic initial steps: importing the data set, X and Y parameters, train test splitting, pre-processing and all that. Okay. Now we have started building our artificial neural network. Okay. So to build my artificial neural network, the first step is what? Initialize the parameters. Okay. So I want to build a simple neural network for which I have one input layer, one hidden layer and one output layer. Okay. So I have taken 3 variables here: input size, hidden size, output size. Okay. So what am I giving in the input here? All the 13 features. So I say input size is equal to X train, shape of X train. Okay. All the 13 features in the X will be given as input here. Okay. And then I am taking hidden size, only one hidden layer with 10 neurons in that, for which I say hidden size is equal to 10. Please understand that 10 is not number of hidden layers. 10 is the number of neurons in one hidden layer. When we proceed with multi-layer neural network, I will tell you how do we define multiple layers. Okay. For now, just remember, this is nothing but number of neurons in the hidden layer. Okay. And then we have taken output size. I am taking only one neuron in the output because this is binary classification. So I require only one output, which will be either B or M. Okay. And then what did we do after initializing the parameters? We have defined a function for initializing weights and biases. Okay. Now when I talk about a simple neural network with one input layer, one hidden layer and one output layer. If I want to make connections between these input, hidden and output layers, what do? I have to connect my input neurons to hidden using what? W1, and I'll connect my hidden neurons to output layer using W2. Okay, so W1 is nothing but the weights which are used for connecting your input layer to hidden. W2 are nothing but the weights which are using for connecting hidden layer to output layer. And then biases, we give one bias for hidden layer. Biases are given for one layer, they are not the connections. Okay, so B1 is the hidden layer bias, B2 would be the output layer bias. So I want to define W1, I want to define W2, I want to define B1, I want to define B2. Okay, so when I am talking about defining W1, W2, B1 and B2, weights should be assigned randomly. Hence we have used which function there? Random. Okay, now first as you look into W1, I am randomly assigning weights in between what? Input to hidden. As you can see, the parameters which I am passing into W1 are input size comma hidden size. Okay, now B2 initially when we go for bias, we take 0 bias. Okay, hence I use the function np dot zeros. Okay, so B1 is nothing but the bias which I am adding for the hidden layer. When you talk about B2, I am assigning random values for W2 with respect to what? Hidden size and output size. Hence the parameters that I am passing are hidden size and output size. Why am I multiplying that W1 and W2 with 0.01? To make sure that we take very small weights. Okay, even though the weights are assigned, even though huge weights are assigned, I want to normalize that to a small value. Hence I am multiplying the randomly generated value with what? A small value which is 0.01. Okay, so I finished initializing W1, W2, B1, B2, and then as I am defining a function, I am returning those parameters. Okay, are you all okay with this? Yes. So what is the next step? Before I actually start with forward propagation, I should define my activation functions. Okay, so in the last class we have defined one activation function. What was that? Sigmoid. Why am I using sigmoid here? It is a binary classification task. So as discussed earlier, for binary classification task we use which particular activation function? Sigmoid. Okay, so what is the formula for sigmoid? 1 by 1 plus exponent of that particular input. Okay, so when I take z as my variable, so sigmoid function using numpy, how am I doing that? 1 by 1 plus np dot exponent of minus. Is that clear everybody? This is defining the sigmoid function which I am using at the output layer. Okay, now I also find the derivative of the sigmoid function. What is the need for finding the derivative of the sigmoid function? Because when you go for back propagation, I have to calculate the derivative of loss with respect to W1, W2, B1 and B2. For doing that, I use my derivative of that particular loss function. Okay, so what is the derivative? Okay, I am calculating the derivative of sigmoid function using numpy again. Okay, now this sigmoid function I am using at output layer, but I also have hidden layer. So what are the activation functions we use for hidden layers? TANH or ReLU. What do we prefer? ReLU. So we also have to define that. Okay, so we'll complete defining activation functions and then we'll start with the 3-step procedure of forward propagation, loss calculation and backward propagation. Is that clear everybody? Yes or no? So what is incomplete in the sigmoid activation function calculation? Defining ReLU which is for the hidden layer. I have just defined sigmoid which is for the output layer. Is that clear everybody? Yes or no? You have to define activation functions for hidden layer and output layer as well. Okay, now let's start working on that. So start defining ReLU activation function which we use for the hidden layers. So what does ReLU function do? Any values less than 0 would be given as 0, greater than 0 would be given as x, the original input, right? So I am defining that function. Not just working from here, you have to start working from the beginning. Okay, I mean run the cells from the beginning. You have to load the data set again, otherwise you will be getting errors when you run this current cell. Okay, please start working, run the cells from the beginning. Okay, you have to load the data set again because we started working again, adding new cells. Okay, see, we have, when you work on Google Colab or even when you work on Jupyter, we have code cell and text cell. Okay, so don't write the text in the code cell, don't run that, you will get error again. Okay, so if you want to work on only the code part, you use code cell. Okay, Jupyter law you can mark down such that the code cell would be converted to text cell. Okay, so did you all finish working on defining ReLU function? Yes or no? Okay, did you all finish doing this? Yes? So what would be the next step? Okay, so we have done with all initializations, defining functions for activation functions and defining function for weights and bias. We'll start with developing ANN now. Okay, so what are the three steps that we have discussed? First is what? How does ANN work? First is forward propagation. Please listen to me very carefully. You can stop working, pause working for a while now. Listen to this and then we'll start working again. So when I want to work on ANN, step 1 would be forward propagation, right? So what do I do in forward propagation? Summation of, when I say forward propagation, please understand this. Summation of Wi, Xi plus B and then apply the activation function. Yes or no? So this is what, this is all about forward propagation. That is, I take my inputs X to Xi, I take weights which are randomly generated, multiply them, take the summation of that, add bias to that, right? So we'll do that, look at that. So we'll implement forward propagation now. So I'll define a function. Let's define a function for forward propagation. Say define forward underscore propagation. Okay, so what are the parameters that I have to give in forward propagation? I need my input X. I also need weights and biases, right? Xi, Wi plus B, right? So X, W1, B1, W2, B2 are the parameters that I'll return into this function. So I'll say define forward propagation, inside which I'll say X, W1, W2, B1, B2. Okay. Please follow us. I will have some questions for you once we are done with this block. Okay. Yeah. When you look at that, what is Z1? Please tell me what is Z1. So I am saying Z1 is equal to NP dot of X comma W1 plus B1. So what is Z1? The connection that I am making in between what? Input layer to hidden layer. Please understand what is Z1. Please remember this. So what is Z1? Connection between input to hidden. That is summation of Xi W1 plus B1. Okay. So what would be Z2? What will be Z2? Before Z1 what did I give? A1, another variable. Please listen, please listen. Just pause it for a while, listen to me and then you can carry on. Okay. See, from next session onward, you will only have to work. I will not come and teach, stand and teach here because everything would be something like this only. Okay. So for today, you please listen. So I am declaring 4 variables here. Z1, A1, Z2, A2. Let us understand them first. Okay. So what is Z1 as I told you? The connection between input to hidden, which is summation of W1 into X plus B1. Okay. Now once I make this connection, I am taking A1. So what is A1? Sigmoid of Z1. Okay. What is this sigmoid of Z1? Hidden layer. A1. Okay. So what is this? What am I doing here? I am applying the activation function for which term? Z1 term. So for one layer, once I am done with summation of my input with that, I am applying activation function. Okay. So do I have to use ReLU or do I have to use sigmoid here? Why? I am not yet done with the output. I am still in the input to hidden layer. Okay, as this is binary classification. See, the reason why I asked you to import ReLU is to make you understand that if you have multi-class classification, you have to do that in that way. Okay, so you can either use ReLU or you can either use sigmoid if it is only binary class for hidden layer also. Okay, that is the point that I want to convey. Okay, now what is Z2 now? Please understand this. What is Z2? Connection between hidden to output. Now when you look into Z2, I am not taking np dot of not x. I don't take x here because I don't want to read my input again. I already have hidden layer which has processed the input, and activation of hidden layer also has been done by A1. So when I take Z2, what do? I take A1. Okay, please understand this. Don't take Z2 is equal to np dot of x again. Okay, so if you have multiple layers, if Z1 is first layer, A1 is first layer, Z2 is second layer. So Z2 will have what? A1. If I have Z3, Z3 will have A2. Is that clear, everybody? Don't take x as input parameter for all the layers in between. You have to take the activated output of each layer as the input parameter for the next layer. Are you all clear with this? Just observe Z2, that is what I am explaining you. Is that clear? So Z2 is equal to np dot of A1 comma W2 plus B2. Okay, and then I am taking A2, which is again sigmoid. Is that clear? And then I'll return what? I'll return Z1, A1, Z2, A2. Now tell me what is Z1? Got it? So what is A1? Activated output of the hidden layer. And then what is Z2? The connection that I am forming with respect to input and weights of hidden to output. What is A2? My final output. A2 would be my final output, that is activation function of the output layer. So A1 is activation function of the hidden layer. A2 is activation function of the output layer, which would be my final output. Are you all clear with this? Yes or no? So this is what I am doing in forward propagation. Okay. So run this cell. Okay. So what is next step? I am done with forward propagation. Now I have to do what? I have to go for next step, which is error calculation or loss function. So which loss function do I have to use? It is binary classification. So which loss function? I explained about three loss function. Mean square error, which we use for regression. Binary cross entropy for binary classification. Categorical cross entropy for multi-class classification. So as the data set that we are working on has only two output variables, B and M, only two possibilities, we go for binary classification. Right? I also explained you what is the formula for binary classification. So let's do that. Okay. So define a function for binary classification. Binary cross entropy. So take a function, define. Now look at this. I am passing two variables here in the binary cross entropy, y train and A2. What is there in y train and what is there in A2? So we have talked about, I told you about four variables, x train, x test, y train, y test. What is x train? Please stop working on it, pause it. Okay, what is x train? Training input data. What is y train? Training output data, which we will give to the model for training. So my model will have access to x train and y train. So it will understand for this combinations or these features of x train, this would be the possible output. So x train and y train are the input and output data that I am giving for model for training. Okay. So along with x train and y train, I have two more variables, x test and y test. What is x test? The input data which I am taking in test for testing. What is y test? The output data that I want to check for x test. Okay. Now when you look into that, for the binary cross entropy function, I am passing two variables. What are those variables? Y train and A2. Why? What is y train and what is A2? White train is nothing but the input which I am taking for testing. A2 is nothing but the predicted output which is calculated by the model. We have taken right Z1, A1, Z2, A2. What was A2? A2 is the output of the model in the output layer. So, for the binary cross entropy, I want to take which input? White train input and produce which output? A2 as output. Clear? So, I will take a variable called BC, binary cross entropy, and define the formula for binary cross entropy using NumPy. Okay. So, I once again repeat, from the next session you have to know the formula for MSc, multi-class classification, and you should do this. We will not tell you the equation for calculating the formula using NumPy. You should read this. I have already shared the PDF right in the group, in which all the formulas are very clearly mentioned. Okay. So, I am defining a function for binary cross entropy for calculating the loss function. Finish this. Is there anybody still doing this? I want to switch to presentation. Okay, make it fast. I want to explain backpropagation with respect to derivatives and chain rule. So, I will switch to PPT if you are done with this. Yeah. So, after I complete forward propagation and loss function, what do I do? What do I do? I will go for backward propagation. So, let's start working on backward propagation. Okay. So, are you all done with forward propagation and loss function calculation? Yes. So, let's look into backward propagation now. Okay. There are three things or three steps that we usually follow for this particular problem statement. Okay. So, as you can see, what I do is, we have to calculate gradients for the output layer. That is, see, all of you please maintain silence. All of you please maintain silence. Yeah. So, when I go with backward propagation, I will start coming from output to hidden. For forward propagation, how did we do? Input to hidden, hidden to output. But when I go for backward propagation, how do we do that? Output to hidden and then hidden to input. So, step 1 is calculating gradients. Gradients for what? Output layer first, and then I will calculate gradients for hidden layer, and then I will return all these gradients. Is that clear? Yes or no? Did you all understand? So, what is the first thing that we do in backward propagation? We will have to calculate gradients for output layer, then calculate gradients for hidden layer, and then we will return the gradients. Okay. Now, let us see how do we calculate gradients for output layer. Okay. So, I am defining three parameters here, dz2, dw2, db2. Now, tell me what is dz2? What is z2? We have already given z1, z2, a1, a2. So, what is z2? The connection between what? Hidden to output, where we are adding bias with weights and inputs, right? So, I want to change the weights here, for which I will calculate derivative of z. Okay, derivative of z2, where my weights, W2 weights would be changed. Okay, and then I will calculate derivative of what? Derivative of loss with respect to W2 and derivative with respect to B2. Okay, so what is Z2? The connection between output to hidden, W2 the weights that I am giving for hidden to output, B2 the bias and that I am adding to the output. So, I will calculate these three gradients in the first step. What is that? D Z2, D W2, D B2. Okay, I will tell you how do we take that. Okay, just now for now you just understand this. And when I talk about calculating gradients for hidden layer, what do? I go for A1. What is A1? The output of the hidden layer, the activated function of the hidden layer. So, I will calculate derivative of A1, I will calculate derivative of Z1, I will calculate derivative of W1, I will calculate derivative of B1. Are you all clear with this? So, these are the gradients that I am calculating. Okay, I repeat, when I talk about gradients for the output layer, we calculate what? D dz2, dw2, db2. When I talk about calculating gradients for hidden layer, we calculate dA1 first, dz1, dw1, db1. Okay, and then I'll return all the gradients. Okay, so let's see next. Look at this, zoom. The input is x. Okay, so what is z1? Connection between input to hidden. So I'll calculate two things there. I'll calculate dou of z1 with respect to w1. I'll calculate dou of z1 with respect to b1. Is that clear? Yes or no? w1 with respect, sorry, z1 with respect to w1 and b1 with respect to, I won't do this first actually. When I talk about backward propagation, I have to do at the end. Okay? Okay. After that, the output of z1 is given to what? A1. So here what do I calculate? Dou of A1 with respect to z1. Okay. And then I go for z2, which is nothing but z2, dou of z2 with respect to A1. Okay. So when I talk about z2, when I go for weights, I'll calculate dou of z2 with respect to w2, z2 with respect to w1, and then finally I'll calculate my a2, which is nothing but my y prediction. A2 is my y prediction, which is nothing but dou of A2 by dou of Z2. And finally, what is the loss function? Dou of loss, which is calculated with respect to my A2. Are you all clear? Yes or no? Please feed this image in your brains. Okay. So first I take X. Next I take Z1. Next from Z1 I go for A1. From A1 I go for Z2. And then I take A2, and that is nothing but the last output, which is the loss function. Is that clear? So for Z1 I have to calculate W1 and B1. For Z2 also I have to calculate with respect to W1, sorry, Z1 it is W1, B1. Z2 it is W2 and B2. A1 derivative with respect to weight and Z1. A2 derivative with respect to Z2. Is that clear? So these are the gradients that we have to calculate. Okay, next slide. Okay, look at this. So first what am I doing? As it is backward propagation, I am coming from the last. Okay, so first I will calculate my dou j. J is nothing but loss function here. Okay, I am using that symbol j for calculating loss function. Okay, so dou j with respect to what? W2. Okay, so I have to calculate loss with respect to A2, which is nothing but A2, and A2 is obtained with respect to Z2, Z2 is obtained with respect to A1, A1 is obtained with respect to 1. You have to calculate your gradients like this. You have to write the code for the same. Okay, next slide. Okay, so I will calculate A2, I will calculate Z2 with respect to W1 and W2 and B2. Next, I will calculate A1, okay, and then I will calculate Z1 with respect to, by changing weights, W1, and then finally I will calculate what? W1 with respect to bias also. So I have to change my weights, bias, and then calculate the derivatives, for which we require partial derivative. Hence I have defined the partial derivative for what? Sigmoid function there in the beginning. Are you all clear with this? Yes or no? I know backward propagation is not that easy as forward propagation, but once you start practicing, you will be okay with that too. Okay, don't worry, as this is your first exercise. We will see in detail on how do we write the code for this backward propagation today. Okay, next slide. Next. Okay, so once we are done with that, we have to upgrade all these parameters, derivative parameters. Okay, let's start working. Please switch on to the Google Colab again, or Jupyter notebooks that you're working. Yes, we'll start working on implementing backward propagation. Okay, we should complete this today. Define a function for backward propagation. Please understand each line of the code. See, from the next exercise, we don't want you to cut and paste the code or just do something without understanding. Each and every line should be crystal clear when you explain the same to us. Okay, so as we have defined function for forward propagation and then loss function calculation, we do the same thing. Define another function for backward propagation as well. Why am I taking m there? I have to consider all the samples in the data set, right? So what does that m is equal to x dot shape of 0 does? Shape is nothing but retrieve all the number of samples. So I am working on 80% of the training data, right? So all those samples has to be taken because the loss function is calculated as what? Average of the distance, average of the difference between actual value and predicted value. Okay. Please understand what is dz2, what is m, what is dz1, what are we doing, how are we passing each and every parameter onto each variable. Okay. So did you understand what is m? The total number of samples, which is nothing but the shape of x. Okay. Next, what is dz2? Derivative of what? Output to hidden, right? Now dz2 is nothing but a2 minus y dot reshape. Why am I doing reshape here again? Because I want my y also to be in a column. Okay. And then I am defining dw2. What is dw2? Weights with respect to dz2. Okay. Now when I do that, look at that. The reason why I take transpose is once you do with derivative, the size of a1 and dz2 would be changed. Okay. So when we are doing derivatives, the size would be changed. So if you don't do the transpose of that, you'll be getting an error saying size mismatch. Okay. So I'll do the transpose for a1. Okay. So what is a1? The activated function. Not all the neurons are activated here, right? So the size is changed. So I'll go for transpose of the matrix. So np dot of a1 transpose with respect to dz2. What is db2? dz2, change of dz2 with respect to b2. Similarly, I will do with a1, dz1, dw1, db1. Once you are done with this, you have to return all the parameters. dw1, db1, db2, dw2. For dw1, the input is x. Okay. See, the first part is about output layer to hidden layer, backward. Second part is hidden layer to towards the input. Ax card, x, only x. Why am I taking axis is equal to 0? I told you in the last class, what is axis is equal to 0, what is axis is equal to 1. Selecting one particular only row or only column. Did you all complete doing this? Yes or no? Okay, we'll give you some time. Finish this. Did you all finish? How many of you are still doing? Okay, please make it fast. Any doubts meanwhile? Does anybody have any doubts in this, till this? Forward, backward, propagations? Any doubts here? Did you all run? No errors.
Okay, I hope you are learning and you are understanding what is going on, right? So, any questions here? I have two questions by the way.
All of you please make note of the questions that sir is putting up after each and every session. Okay, they would really help you in interviews or further things. Okay, so please don't just listen to the question and just forget about it. Okay, make note of all the questions that sir is asking you. Okay, yeah.
So, question number 1. Since you calculated loss function, you calculated loss, okay, there is a gradient, and then you're trying to back propagate. What value you're rectifying? finally. You saw the loss, you are going to rectify some certain value so that the loss is minimized. So what value you are rectifying? Weights. Okay? So you're rectifying weights, very good. Now I rectified weights, then how should I go ahead? Yes, I rectified weight, but how that changes will happen, and my final output will be affected with the updated weights. How is that going to happen? Have you seen that? Have you seen that till now? Please check that. See, yes, of course you have not seen it, but because there is this question number 2 is based on that. Observe carefully, right? Okay, Asha, go ahead.
So now listen to me. So once we define this, we have to update the parameters. Why am I updating the parameters? The weights are getting changed, so I have to update the parameters. Okay. So the next step after backward propagation would be what? Updating the parameters. Please take a text cell and write update parameters, and let's start working on how do we update the parameters. Once you are done with backward propagation, we will have to update all the parameters that we have declared now. Okay. All of you are working simultaneously. Yes? Is there anybody just sitting and listening, or are you all working along with us? How many of you are just listening? Okay, we are glad. Okay. So I am defining another function for updating the parameters. So I say define update parameters. So what are the parameters that I want to update? First I want to update W1, B1, W2, B2, and in backward propagation I also want to update my derivatives, right? So I say dW1, dB1, dW2, dB2, and then I say learning rate. Okay. So learning rate is a parameter like to have faster convergence. Okay, in the backward propagation when the gradients are getting changed, we go for adding a parameter called as learning rate. Okay, that we have discussed in the last session. Okay. So I say W1 is equal to W1 minus learning rate into W2. See, learning rate is a small value, okay, that we add when we are updating the parameters. Okay. So 0.01 akkada add chesam, similar to that, for even if the weights are getting changed again. Okay. So again we have to multiply that with the learning rate to get smaller weights. Okay. See, your neural network, depending on the data, this is a small data set with 100 samples, but in fact we may work on millions of samples. So when you work on millions of samples, it may take 100 epochs or 2000 epochs for us to get the good results, and this process would be repeated so many times. So when you update weights so many times, sometimes the values of the weights would be finished. Okay, so that is called as gradient descent problem. So we either have very small values of gradient, exploding gradients or vanishing gradients. So in order to avoid that, we'll add this small parameter called as learning rate. Okay, because we won't run the neural network only once or twice. We may run it some million times. It may take days or weeks also when you work on real-time data sets. Up to so many times you have to update weights and check. So if you multiply that with a small value, you may have many possibilities of generating weights. Got it? So I say W1 is equal to W1 minus learning rate into dW1, and then similarly I will do it for B1, W2 and B2. I will return all these parameters. Update the parameters with respect to learning rate W1, B1, W2 and B2. Okay, training loop. Did you all finish updating the parameters? Yes or no? Okay. Now what's next? What's next? I've completed my forward propagation. We completed loss calculation. We completed backward propagation. So are we done here? Are we done with the model development? Do you get result only after once backward propagation? I have to run this n number of times till I get the desired results. So I have to put this in a loop, training loop. That is, please do forward propagation, calculate loss, do backward propagation and update the same thing some 10 times or 20 times till you get the desired result. Okay. So we'll define a function for training loop. I want to train the model now. Okay. So we have just completed forward, loss and backward propagation. Now I'll train my model by putting that into a loop. I didn't work on training the model yet. I have to join all these functions that I have defined. We have just defined functions for forward propagation, loss calculation and backward. Now I want to train my model with respect to these three parameters or these three functions. Okay, so I'll define a function called train model. Now listen, all of you please pause for a while. Please pause for a while and listen to me. So I'm taking a function called what? Train the model, train underscore model. What are the parameters that I'm initializing in this? Please look at that. What is X? Input. What is Y? Output. I'm giving the dataset input and output. Apart from that, I'm also giving the hidden size and I'm also giving my learning rate because I want learning rate when I go for changing my weights. Okay. And then I'm giving epochs. Okay. Epochs is nothing but the number of times I want my process to happen. Okay, number of times my iterations takes place. Okay, so we have to define each of them now. Okay, so I say input size. What is input size? Shape of X. Okay, that is 13 features would be taken, and then I'm taking only one layer of output, one neuron in one layer of output, that is output size is equal to 1. And then I say, look at that. What am I doing after that? I am initializing those weights. I am putting it in a training loop. Whatever I have done, I have just defined the functions there. Now I am putting all together in a loop for training the model. Okay. So I say W1, B1, W2, B2. I am initializing those parameters. We have taken the function initialize parameters, right? I am just calling that and putting it in a loop. So first we have taken input size, hidden size, input size and output size, and then we have calculated W1, W2, B1. See, we are calling everything that we have done step by step in the training loop for training the model. Okay. So I am taking a simple for loop and say for I in range of epochs. I want to run this for 10 times or 20 times say. Okay. So I'll put it in the loop. Why am I putting it in the loop? Forward, loss, backward. Again I have to go for forward, loss, backward. So I want this iterations to take place. So hence I am putting that into a loop. Okay. So how many times depends upon the number of epochs that we give. So after I initialize W1, B1, W2, B2, I'll go with Z1, A1, Z2, A2, that is forward propagation. Do it simultaneously along with us. If there is any doubt, please raise your hands. All the mentors and myself are available here, so we will come and clear the doubts. Don't just sit idly or don't just listen to us. Please work along with us simultaneously. So first W1, B1. Next in forward propagation I said Z1, A1, Z2, A2. After forward propagation, I will go for calculating binary cross entropy. After that, I go for backward propagation. Yeah, first complete this, we'll tell you. Okay. So I want my ANN model to run 1000 times for 1000 epochs. Okay. So if you run for 1000 times, I don't want my 1000 times to be displayed. I only want for every 100 epochs my result to be displayed. So that is the reason. In I take my epochs which are 1000. Okay. And then I say I am dividing that by 100. So that only 10 times for every 100th time my epoch result would be printed. Okay. So we will have few questions for you based on this. Why are we using flatten? Okay. So we want you to work on each and everything. Without doing that, what will happen? With flatten, what will happen? Okay. What is the need for taking flat, or why do I have to flatten the data here? When I calculate accuracy. Okay. Okay, mom. From the beginning. Let's start it from the beginning. Down. Yeah. Did you finish? You didn't finish this? Okay. They didn't finish. Okay. Now for running the model, I have to give the number of epochs on what data I have to run, right? So I'll say train model. So the model should be trained on which data? X train and Y train only, not the entire X and Y, right? So I'll run the model for what? I've already trained the model. Now I want my model to be run on what data? Only X train and Y train. So I say train the model with respect to X train, Y train, hidden size, learning rate and the epochs. Okay, you can give 1000 epochs, you can give 10,000 epochs, that is your wish. Okay, so more times you run, more the accuracy or the result would be changed. Okay, so for now let's take 1000. Did you all finish till this? Okay, let me explain you the training loop first. Okay, okay, madam, please come down. Yeah. Now listen. So what did we do in training loop? I want answers from you. You have seen what did we do. So what did we do in training loop? We have defined a function for forward propagation. We have defined a function for loss function. We have defined a function for backward propagation. We have updated the parameters. After that we are training the loop. So what am I doing in the training loop? Please tell me, what am I doing in the training loop? This is most important. So far we have just put it in different parts. So training loop actually combines all the modules that you have worked on so far. Okay. So what is training loop doing? Yes, it is repeating forward, getting connected to loss, calculating loss, understanding that loss is too high such that I have to go for backward propagation, and then again go for forward, calculate loss and this. So this I am putting it in a loop by training the model. Okay, and what is epoch? Epoch says how many times do I have to run this particular loop. Okay, so how many epochs did we take? 1000. Why am I taking I by 1000, by I by 100? Because I don't want every epoch to be printed. I want, so you can skip this step. For ease of understanding we have done that. Okay, when I divide that by 100, only 10 epochs would be printed. After every 100 epochs it is printed once. So I want only 10 epochs to be printed after every 100 iteration. Clear? Yes or no? So when I am training the model, I train my model only with X train and Y train, not the entire X and Y, because I have reserved some part of data for X test and Y test also. That is the reason when I am calling the train model, I say train the model with what? Only X train data, Y train data, hidden layer and then back. Okay. Now look at this. When I say after epochs, what is that Z1, A1, Z2, A2? The parameters after the forward propagation. After forward propagation we go for loss function, that is binary cross entropy. I am taking a variable called cost here. Okay, so I want to replicate it to the figure that I discussed in the slides. Okay, so cost is nothing but the loss function that I am taking with respect to binary cross entropy. So forward, backward and then I am updating the parameters W1, W2, B1, B2. Okay, so for 100 epochs I want to run and then calculate the accuracy. So what is accuracy here? What is accuracy here? How do you calculate the accuracy? Actual value minus predicted value. Okay, so do I have to take accuracy only for one sample? I calculate accuracy for all the samples. So I am taking mean. Okay, now in the next class I want you to tell me why did I take flatten there? For what? For getting the values in a single row. Why? Why? Because Y is a 1D array. Correct. Okay. So I want to calculate my accuracy. Okay. Next. Up madam. So here we train the model with respect to X train and Y train. But we are getting error. Did you all get the error? I want all of you to get the error here. Do you see the error? What is the error? What is the error there? I double equal to, is that the error? So shall I say 1 out encoding today or in the next class? Then we have to discuss that the next class because it takes some time, 15 to 20 minutes, 15 minutes, because I have to go back to the code. Okay, so we'll stop it here for now till training loop. I'll tell you what is the error, how do we solve that. Another pre-processing has to be done. Okay, so we'll discuss that in the next session. Okay, so what did we see today? What did we do today? Okay, let's discuss how do we develop ANN model. What is step 1? Step 1, import the libraries. Step 2, load the data set. Step 3, initialize X and Y, input and output, independent and dependent. Step 4, standardization, normalization. We generally call this as pre-processing. Depending on the data set that we work on, we have to either go for standardization, normalization, pre-processing. After pre-processing, split the data set into train data and test data. After that, step 6, building the network. How do we build the network? Step 1, initialize the parameters. Step 2, define the functions for what? Weights and biases. For initializing weights and biases. Step 3, define the functions for activation functions. Okay. Next, step 4, implement forward propagation. Step 5, define loss function. Step 6, implement backward propagation. After that, update the parameters. After that, training loop and then calculate the train your model in the training loop and then calculate the accuracy. Okay. Now listen to me. All of you please pause for a while and listen to me. All the ANN models will have the same steps. But what would be deferred? X and Y. The data set would be changed. What do you take in X and what do you take in Y? You should understand. The data set would be given as raw. You should know. See, in this I have taken diagnosis as my output variable. So you should define what would be the input variables, what would be the output variables. This is the first change. What would be the second change? Depending upon the data set, depending on the output variable that you take, you say whether it comes under classification task or whether it comes under regression task. When I say temperature prediction, temperatures will have continuous values. We go for regression task. Okay. When I say breast cancer prediction or whether you pass the PS exam or not, this is a classification task. So the loss function would be changed. X and Y declaration, loss function changing would be changed, and then number of layers that we take would be changed. Okay. And then when we are going for backward propagation, as I told you, what are optimizers? The algorithms that we use for changing the weights. So we use different optimizers in different exercises and then we'll repeat this entire process. Okay. Loss function would be changed, optimizers would be changed, data set would be changed. So we will just give you a data set. We will not tell you which algorithm you have to develop. I just say develop an ANN model for this particular data set. So depending on the data set, you should choose whether it is regression or classification. You should define your own loss functions. You should define which optimizer to select, which activation functions to select and develop the ANN models. But the steps would remain the same. Is that clear, everybody?